So. Three, 4, 3, 4. We're just doing a bit of a sound check, and instead of 1, 2, we're going to go higher because why not? So start in a couple of minutes. Hi everyone, it's Twitch time again. I'm starting a couple of minutes just to give people time to join. For those of you that are watching live, there's a chat box where you can ask questions and we'll get to them at the end. And for those of you watching on catch up, don't. But my email address is on the screen. If you ever have a question, you can just email me and I'll respond at some point. It's an asynchronous process. So what we're wanting to talk about today is how you can bend the rules on serialization. Bend but not break. If you break your rules, you're going to break your application. But this kind of came up in conversation. We were just kicking about with some of the people in Hazelcast engineering, and it was like, yeah, how do we do this? And it's like, yeah, well, here's the way we would do it. And I thought, yeah, that will be of interest to other people as well. So that's the topic of today, is how to bend the rules I'll start with a couple of slides, but it's really going to be about the code. So let's rattle on with the slides. So it's not bending the rules on serialization, it's bending the rules on serialization and deserialization. Really, what are those rules? So, it's only actually one, I would have said. If we think of what serialization is about, serialization takes your domain model and turns it into a stream of bytes so that you can send it from client to server, process to process, all those kind of things. That is very much Java focused, but you get serialization in other languages, but we're just going to start with Java here and then go on to it. So that things make a bit more sense. So if you look here under the word serialization, I've got a Java class which is serializable, and that class contains a field for first name, which I've given the value of Neil. So in the yellow might be how you see the code. And when you serialize it, Java turns it into, let me hang on. Somebody's got some difficulty seeing my text, so I'm going to resize my screen. How is that? So, yeah, that yellow piece of Java code representing this class, it just gets squashed and flattened out. So what that means is you send the code, you send the class name, and then you send the fields in the class. And because the class name is a string, there's maybe some sort of string end character, or perhaps you send the length of the string first and then the bytes of the string. But that's all kind of there in serialization. And deserialization is just the reverse. So you take that stream of bytes and you turn it back into a Java object. You do a new object and then you set the value of the field. And really the rule is that deserialization needs to do the reverse of serialization. So if serialization does something strange, deserialization needs to be doing the same strange thing. Because really what you want is you send some data in and you get it back out, because otherwise it's no use. And that's particularly relevant in Hazelcast because your client puts some data in a Hazelcast cluster and then another client might read it a day later. Well, if it's been put in wrong, you're going to have no hope of getting it out right. But in a little bit more detail in Java, many of us will actually have seen Java's serial version Uuid and wondered what on earth it was. It's part of Java's mechanism for serialization. And basically, what I've done is I've expanded my class now, made it a bit bigger. So my person class has got a first name, a last name, and a field. So those are two string fields, and this is a passport field, which is a different kind of object. And a passport has a passport number and a reference back to the person that holds that passport. Because this is part of the challenge of serialization, is you've got objects that refer to other objects, and they may be like an object graph, meaning it's in a circle, or it may not. And what you do is when you serialize the object, you have to give it some sort of reference number, and you have to give it an object version, and all sorts of bits like this. So what may appear in the byte stream is first of all the object name for the person, and then its serial version UUID, that yellow number, which is how you know what version of that domain object it is. Then perhaps a counter, and then I'm going to have to resize this. I'm still having trouble with my screen. Is that better? So you send a counter, and then you send the fields, and then when you're doing the passport object, you need to know what a person object it belonged to. So it's person object number 1. And you'll see there when you're sending something like a numeric field, you know how big it is. An integer is going to be 4 bytes, a long is going to be 8 bytes. So you don't have to do any kind of field separators. And then just the last piece on this, just before we go into it in detail, is this might actually be your object. My name is Neil, N-E-I-L, but I might serialize it into uppercase. It's uppercase in the bytes, and when I deserialize it, I go back into lowercase. So as long as your serialization and deserialization match, and this is how you bend the rule, you don't have to send what's actually stored, as long as you have a way to get back to what you have. So a more realistic example might be if you were sending a list of items, well, maybe the first thing you send is the list size. And if list size is 0, then you don't need to send anything more. So you can, on the receiving side, oh, my list is going to be 0, I'll just create a new list, and I don't need to do anything else. But that's enough of slideware. Let's have a look at some code. And apologies if that didn't display this correctly on the screen. So some code. In fact, let me link to this code up here. It's Hazelcast Airlines in the Hazelcast code samples directories where a lot of this is being copied from. So in Hazelcast Airlines, we're going to create an object, and we've been very good. We've written some unit tests here. So we're just going to run that unit test, and what that will do is, maybe the test passed, that's always a good start. So what that will do is take that object and write it, do a write object, which writes it into a byte array, and then we just dump that byte array to the screen. And normally you would send a byte array across the network and unpack it on the other end, and that's how you push and get data into Hazelcast. But this is what the byte array actually looks like. In the bottom of the field, you're seeing that the bytes, well, it's 1,127 bytes long for that object, and the first byte is minus 84, then it's minus 19, then it's 0, then it's 5. What on earth does that mean? And if you start to look at it, you see here's the data that's actually inside. And one of the things that starts with is here's the Java class that follows. And you'll see it's got the full package name. So if you refactor your code and make your packages different, you're going to change the size of your serialized object, which is how it's stored in Hazelcast. So somebody doing something architectural, like repackaging, can make your code take a different amount of size to store in Hazelcast. And obviously if you need more servers, that's more hardware. So it shouldn't really be connected. So Java serialization is kind of a bad choice for a number of reasons. But let's have a look at the little example I did for today. So I'm going to set up a Hazelcast server, and because this is going live to the internet, I want to be seen to be a good developer, so I'm going to put some tests on my code. And this code will, when it opens, it's going to take my data object, it will serialize it, dump it to the screen. It's the code I've copied from the test below. And this will tell us how big this data object is. And the data objects I'm going to measure is I've got an entry processor and a callable. Now, if you're not familiar with what those are, a callable is like a Java stored procedure. You run it and it does something, and it returns an answer to you. So you use that for server-side processing. It's a bit like a stored procedure in a database. If you're familiar with those kind of things and you're not a Java person. An entry processor is a more specialized version of the same, essentially. It mutates a data entry or works on a data entry. So you send it to a particular key and you say change this key in this way. So it's a way of applying kind of delta functionality. Because if your data object in Hazelcast is huge and you only want to change a little part of it, well, you want to retrieve it all the way across the network to your client, change it, and then shove it back across the network into the server. Simpler maybe just to change in process. So that's what those tests will do. And let's have a look at our data. And this is my example of how to do things well. Maybe not necessarily true. So we're going to give up on Java serialization because it doesn't run particularly well. I mean, it's fine, it just produces very big objects and uses a lot of CPU, and it's not much use for non-Java. So we're going to have a serialization factory. It's a class that creates data objects. So for no particular reason, I've given my factory a code 9999. My entry processor's got a code number 1, 1 plus 9999, 10,000, and the callable has got 1 plus the line above, 10,001. So I've just got 3 constants there, and I do this 1 plus x thing to try and make sure they're unique, because as I mentioned, if serialization goes wrong, then it can be quite difficult to debug. So what my factory does, and this runs on the receiving side to do deserialization. So when it receives in an object of a particular type, if it's code 10,000, it creates a new entry processor. It logs it as well, which is generally something you wouldn't want to do, but it's just for demonstration purposes. And if it's a callable, it logs it and creates a callable. And that's it. That's all it's doing, is a callable, creating an object of this type or that type, depending on the code number it's been passed. And if we look at the callable to see how it does its serialization. So I'll talk through how this works if you're not Java friendly. So my class, my callable object, my store procedure has 3 attributes. So here's the call function itself. This is what it actually does. It logs that it's actually running. It figures out the name of the Hazelcast instance it's running on and where it's running, and it returns that as a result. So it's not really doing anything other than telling you which Hazelcast instance you're connected to, and there's other ways you can find that out. This section here is Hazelcast giving, we'll plug in a reference to the place where that callable runs. Now for serialization, there's kind of basically the way it works is when you send an object, the first thing you send is here's the factory that's going to create it, then you send it the class ID, and then you send it the fields. And this class has got no fields, it's purely about processing. So basically when I send that, what I'll send is the factory number and the object number. Hazelcast sees the factory number, knows that that factory is associated with this class, passes it the object type, which was the second thing on the byte stream, and the object type tells it what kind of thing to create. So that's how serialization works on the server side. On the receiver side, you get a code number that says I'm an object that is built by factory 123, and my class is 456. So Hazelcast knows which factory to code, what argument to call to put the data in, and out you get a data object. And if we have a look at the entry processor, which does a slightly similar kind of thing, so it's got well, let's have a look at its serialization. So my entry processor has an argument, a field, an amount I want to process my entry with. And basically what I do is I get the value from my entry and you add the amount. So basically it's like you use this to add 5 to a number or 10 to a number. It's not particularly complicated business logic, because that's not what we care about here. And again, we've got the same serialization. So to send this data, you need to say this is the factory that will unpack it, and this is the type of object you need to tell the factory to enable it to unpack it. And when you actually send it, you want to write out that field up here. And when you receive it, you take the field from the byte stream. And then the last part of this is not there, is configuration of Hazelcast. Well, there's a couple of bits going on here, but basically I'm telling Hazelcast that use for factory ID 9999, I want to use that factory. Now let's run our test and see what it actually does, because that will make things a bit clearer, hopefully. Running the test. I'll put it bigger. There we go. Right. So, here we go. So when we serialize my entry processor, in fact, let's look at the callable first. When we serialize a callable, it's 17 bytes long, and what we'll see is it's got a string of numbers. Now that number, these numbers mean things to Hazelcast, but what we actually see is there's the factory number. So those of you who are familiar with bytecode will understand that that actually corresponds, that's an integer that makes it Let's see if I make this screen bigger. No, it's not resizing. Let's see if we can make this a bit bigger. Can we see that now? Is that better? So basically what I was saying is that when we send this object, there is the factory code 0015 that appears in the byte stream, and then there's the object code 0017 or 003916. So that's 10,000, that's 10,001, that's 9999. So what we see is that when we send the callable, what we actually send across the network is some Hazelcast headers, but it's like there's the factory code, there's the identifier for the class that will build the object, and there's the object that we want built. And it's the same for this, except we've got one extra bit on the end, which is an integer. It's the value of the amount field. So basically, if we've got fields, we just list them out one after the other in the byte array. Now, the important thing here is that this is just bytes. It's got nothing to do with Java. It didn't have the class name in there or anything like that. So we can have a different class, a different object, writing the byte array. And in this case, I'm going to do it with Python. So if we just start up our Hazelcast server. Let me move this over here. Hopefully this all displays nicely. I'll let this start up. So there we go. And what I've created in my Hazelcast server, there's a map called Neo, and I've put in 5 integers. So key 0 has the value 0. Key 1 has the value 1, key 2 has the value 2, and you can guess the other two. So that is my test data. And what I want to do is use a Java client to connect to my Hazelcast cluster and invoke those stored procedures. So let's have a look at the Java client now. So close all these things down. Now, move this over the side a little bit. Let's have a look in my Java client. Now, one of the things that's in my Java client is you'll see that I've actually got a copy of all the same information that's on the server side. And that would normally be like a bit of a bad practice, but here I'm doing this deliberately now because my callable object, and this is where I'm bending the rules. Wait for the class to finish. Let me just move that out of the way, hold on. My callable object on the client is different from the server, deliberately. So this is me bending the rules. So basically the serialization is the same. So when I create that object on the client and transmit it across the network, that definition matches the definition on the server side, because these are the same. This isn't present on the client side because it doesn't need it, and that's me cheating, that's me bending the rules. And this method has a different implementation on the client side because the client doesn't actually run this object, it just creates one, sends it across the network, it unpacks into this one, which is different, and executes on the server side. So because it's different, this is where you can be too clever. So that, now, literally too clever. I do this is my 9 to 5, and I get it wrong all the time. So if you're doing this kind of approach, you've got to be super careful. Because when it goes wrong, it's very difficult to trace. Did you call it wrong? Did you invoke it wrong? But my client will basically send a callable, and basically all it will do is figure out what these fields are, send them in the byte array, and that's what goes on the other end to build the actual object that gets run. So it's kind of like call by reference rather than call by value. I create an object on the client, I flatten it into bytes, and I send the bytes onto the server side, which recreates actually a different object. and it's different in a controlled way, so it will work, but it might be different in an uncontrolled way and go badly wrong. And if we look at the entry processor, it's the same idea on the client side. The process method isn't implemented because the client doesn't run that method, doesn't do that processing. So let's see this from Java. So look at this, my maps are still 0. So while we're here, I want to run up my Java client. And just while I'm waiting, I'm going to run up my management center. So what we see is my Java client has started. It's made a call on the entry processor on key 3, and it's called on key 3 with an amount of 2. So that was the argument it passed, and that has returned an amount of 5. So basically what I've done is I've added 2 to the key with a value 3. So I have invoked a call on that callable. And if we look on the callable, what we'll see on the server side is that key 3 has been changed from the value of 3 to the value of 5, and here's what we're seeing on the callable. There's the callable has been unpacked on the server, so that's my stored procedure, if you like, being unpacked, and there's my stored procedure being invoked. And here's the same idea for the entry processor. We'll see the factory creates an object of type code 10,000, which is the entry processor. Then it calls the process method, which is just logging what it's doing and returning it to the client. So the client call in Java code is this. There's a little bit, but basically I submit my callable object, I submit my callable object and it gets me back a string, which I'm just printing on the screen. And then for the entry processor, I'm just picking up a random key between 0 and 5 and a random amount between 0 and 3, creating an entry processor, setting the amount and running it. Let's run that Java client one more time. And what we'll see is that we're on the callable again, which doesn't make any changes server side, so it gets the same answer, and it will randomly pick, it's randomly picked the same key, but it's definitely random. It's added 1 to it this time, so key number 3 has got the value 6, and it will sleep for a minute or 2. And if we like, we can go and look at our management center, which is on port 8081 for no real reason. What we can see is that there's my client is connected, it's coming on that connection, it's Hazelcast 5, and it's a Java client. And if we wanted to, we could look at the maps as well, but we're not going to bother because it's just printing them out on the server side anyway. So we know that the current value of key 3 is 6. So that's doing it from Java. And to show it interoperable, we're going to do it from Python, because this is where the whole point of it comes in, because you want to be interoperable, then you want to call from languages to languages. So we want to do that same definition in Python, because Python can invoke a function on Hazelcast in the exact same way as Java. Now, I'm not, I won't go into all the detail of Python. It's more or less the same idea. In fact, it is exactly the same idea. It's just a corresponding implementation for that language. Your entry processor has factory ID 9999 and class ID 10,000, and your callable has 9999 and it's 10,001. And this is the point. If I was to code that's 10,002, this would go horribly wrong, because the processing is not going to know what's gone wrong. You're passing it a code that it doesn't have, and it will explode. In fact, we'll maybe try that. But first of all, I just want to show you it working from Python. So we connect to Hazelcast, we create a callable, we run it, and we get back a result which we print out, and that will be our string. And then we pick a random key, and we do the same. We run an entry process with an amount, and we print out what it's got. So if we do this from Python, if we just have a look at the code there, I've hardwired in somewhere in here my connection There we go. So my build timestamp appears as a label, which is sometimes useful. So if I just run that, then what it will do is it will connect to my Hazelcast cluster, run on localhost. It calls the callable, and we see it gets back the result, which is the hosting port it's running on, and this time it's picked key 2 in an amount of 0. That's not very interesting. So let's run it again, and this time it's picked key 0, and it's got an amount of 2, so it's turned key 0 into 2. And if we look on our management center, then what we'll see is there's our Python client, and we can get the build label off that if that was a thing we were interested in. Whoops, back I go. Done that twice. I'm trying to get, there we go. Yeah, there you can see the build label, and we can, there's rather a lot of fields. So in the next version of the management center, that's multiple panels for this, so you can see different parts. But basically it's a Python client that's coming from that address, and it has that function, and I've given it this name. So what we're going to do, just as the last part, because I thought I'd talk for about half an hour, we've got a couple of minutes left, is we're going to change the factory number that we send for callable. So let's change it to 10,002 and see what on earth happens. So if we look server side first of all, we'll see that key 0 has got the value 2 because we incremented it, and key 3 has still got the value 6 because the server isn't really doing anything. And I'll just run my Python processor again, and what we'll see is that has sent and worked correctly. So it's done add 2, and there we go. So it's received 10,000. So what have I done wrong? And anybody that's clever can tell me, but I actually know because I'm stupid. What I've done is I've changed my source, but when I executed the Python, I was running it from the compiler version. So all I need to do, rebuild it. And now I'm hey, look at that, something's gone horribly wrong, because when I've sent that 10,002 to the server, it's asking, it doesn't know what to do. Create 10,002 is unknown. So that is how it's going to go wrong if you get it wrong, if you break the rules rather than bend the rules. Because on our server-side coding, we'll see the factory, it knows what to do if it receives a 10,000, it knows what to do if it receives a 10,001, and in this case we sent it a 10,002, so it didn't know what to do, didn't know what kind of class, and in this case, logged an error and goes wrong. So helpfully here it failed fast, but if we'd done something different, it might have worked. We might have serialized it, and then when we retrieved it, maybe it's not got the fields we expected, because maybe it's got 5 fields in your object and you only serialize 4 of them, so you've lost some of the data. But you wouldn't know that until you tried to deserialize. So these things can go horribly wrong. So there's an example of it going horribly wrong. You just need to make sure that those numbers are set the same everywhere, because without that it's not going to work. And then the mechanism for how you populate the fields on the object is up to you. So in this case, the amount field is an integer, I'm sending it as an integer. Well, I could send it as a long, I could send it as a 64 byte field rather than a 64-bit field rather than a 32, and I wouldn't lose any precision. So it would just make my data packet 4 bytes bigger. So it's an integer, it fits in 4 bytes. I could send it as a long, which is 8 bytes. And then I just need to take the lower 4 bytes when I unpack it. So that's the kind of cheating you can do. And changing this to different values is the kind of cheating you can't do. So that's kind of it. That's the story for today. So when you have a language like, let's just say Python, you can use the Hazelcast client. You need essentially a stub definition of the entry processor. we don't care about the business logic because it doesn't run client side, it runs server side. And all we do is create the object here, and we say execute that on somewhere on the cluster. In this case, the member that owns the blank key, because there's always going to be one of them that has that. And it's the same for the entry processor. You create the object and you execute it and you get back a result. So, any questions at this point? And apologies, screen sharing seems to have missed a couple of bits off the bottom edge of the screen, and they were the really good bits, I'm sure. I'll hang on one more minute for questions, and then I'll stop broadcasting. So then you remember just two things to show. If I go back to my so the code was on github.com, Hazelcast/Hazelcast code samples, Hazelcast code samples, live typing, and then what you're looking for in here under the serialization examples, you look for Hazelcast Airlines, and it will show you the code that does the serialization tests. Because if you're doing anything clever with your serialization tests, this is the serialization test for Java iOS serializable. What you want to do is make sure that what you send in and what you send back are equivalent, so they're the same object, and no, they're not the same object, they're the same class, they're two different objects, and they have some sort of equality. Now, equality is something you have to make sure you implement correctly, but fundamentally, if you're going to start doing this kind of going off piece to do your own style of serialization where you don't send the data exactly as it's held, then you're taking that on your own head, that you make sure you test it thoroughly, because as you've seen, you saw me doing it and I got it wrong, and it's like, yeah. So fortunately I spotted what I'd done wrong, but if you put bad data in your cluster and you get it out, then you've got bad data, and what can you do about it? So that's me. No more questions. I will stop broadcasting. And don't forget to tune in next week.